If you're sharing a hotel room with friends, you're also
Hey everyone, it's me again, and in this video I'm going to explain the selection sort algorithm in computer science. As always, sit back, relax, and enjoy the show. Okay everybody, selection sort. Selection sort is an in-place comparison sorting algorithm that keeps track of the minimum value during each iteration, and at the end of each iteration, all we do is swap variables. How I like to imagine this is that let's say that our array is a bunch of different closed boxes, and each box contains a number, and they're all out of order. So what we'll do is we have a flashlight too, because we're in the attic and it's really dark. So we have a flashlight. We will open each box beginning with the beginning of our array, and we'll take a look at the value inside. Okay, 9 is a fairly small number, I guess, right? So we will move this value to some temporary storage. We'll keep track of the index of the minimum value. 9 is the new minimum. Let's open the next box, and holy crap, it's a 1. 1 is a really small number, so that will be the new minimum. Then we'll open the next box, which is an 8. 1 is still less than 8. Let's move on. The next box is 2, 7, 3, 6, 4, and 5. 1 was the minimum value during this iteration, and we need to move this value to the place that we started during this iteration, index 0. So we'll have to do some good old variable swapping. So we will take 9, place it within some temporary storage, then take 1 and place it where 9 was, then take 9 and place it where 1 was. And that is the first iteration. Let's move on to iteration 2, and we'll clear min and temp. Okay, so this portion is done now. We're not worried about it. This is the new beginning of the next iteration. And well, 9 is a low number, I guess. We'll move that to min. But 8 is even lower than 9, so we'll move that to min. Holy crap, it's a 2. 2 is the new min for sure. And then we just repeat this process over and over again. 2 is the current minimum of this iteration. 1 was the minimum of the first iteration, but we're not concerned with that. It's already sorted. So we need to move 2 to where we began this iteration at index 1. And currently there's a 9 in there, so we're going to evict this 9, place it within some temporary shelter, take 2, place it within where we started at index 1, then take 9, place it where 2 was, and that is the second iteration. Now that we kind of know how this process works, I'll speed up the rest of the video for this demonstration. So let's begin at index 2. And that is the selection sort algorithm.
My name is Esperanza and I'm currently taking the quantum.
The selection sort algorithm has a runtime complexity of big O of n squared. The larger the dataset, the more and more inefficient that using the selection sort algorithm is going to be, although it's okay with smaller datasets. Now let's create our own selection sort algorithm. Okay, let's implement a selection sort. We'll need an array or other collection to work with. Let's create an array of integers because I want to make this as easy as possible. So integer, array, and make up some random numbers, make sure that they're not in order. What about 8, 7, 9, 2, 3, 1, 5, 4, 6, I guess. Then let's use a for each loop to iterate over the elements of this array. For int I in array, we will display each element with a print statement. System.out.print I. And let's run this once just to be sure that everything is working fine. So 879, 231, 546. Everything is working as it should. So before we display the elements of our array, let's invoke a selection sort function, which we still need to declare. So selection sort, and we will pass our array as an argument because, well, that's what we want to sort, right? So selection sort, and we'll need to create this method. I will cheat and use the shortcut. So outside of our main method, let's declare private static void selection sort. There is one parameter, an array of integers. We'll need a pair of nested loops to iterate over our array. So let's work on the outer loop. For int I equals 0, we will continue this as long as I is less than array's length property minus 1, then increment I by 1 during each iteration. Then there is a nested loop. Within here, change I to j. So j equals I plus 1. J is less than array length. And j plus plus. So we'll need to keep track of the minimum. So we'll do that outside of our nested loop. Int min equals I. So that is the current minimum. And within the nested for loop, we will check to see if our array at index of min is greater than array at index of j. If it is, we will change our min to equal j. Then outside of our nested loop, but within the outer loop, we will do some good old variable swapping. So int temp equals array at index of I to store this element array at index of I equals array at index of min. Then lastly, array at index of min equals temp. And that's all there is to it. So after running this program, our array is now sorted via the select selection sort algorithm. Then of course, if of I equals array at index of min. Then lastly, array at index of min equals temp. And that's all there is to it. So after running this program, our array is now sorted via the selection sort algorithm. Then, of course, if you need your array or collection sorted in descending order, currently it's
I applied to over 200 tech jobs and got rejected from every single one of them. And then I found out about others that were landing.
In this video, we're going to be coding the selection sort sorting algorithm from scratch in Java. It only takes a few lines of code, so it's a great programming exercise for beginner programmers. I also have a full Java course available in a link down in the description. I've recently added a whole lesson all about Java streams to the course that a lot of people have been asking about. So go check it out. Okay, so we'll jump right into the code in just a second, but first it's a good idea to talk about exactly how the selection sort algorithm works. So let's say you have an array of integers like we have here. The job of the selection sort algorithm, or any sorting algorithm, is to put these elements in their natural order, which for integers is going to be least to greatest. So let's look at this set of integers as an example. So we start at the first position here. And what we're going to do is search from this point in the array all the way to the end, and remember the index of the smallest number that we find. So we do that starting at 4. So the current lowest number we've seen is 4. And then we look at 5. Now, is 5 less than 4? No, so 4 is still the lowest that we've seen. And then we move on to 1. Is 1 less than 4? Yes, it is. So far, 1 is the lowest number that we've seen. And then we'll move on to the 2. Is 2 less than 1? No, 1 is still the lowest. And then we move on to 3. Is 3 less than 1? No, 1 is still the lowest. So now we've gotten to the end of the array, and we know that the number 1 is the lowest number that we saw. So what we're going to do is swap this 1 with this first position that we were looking at. So we put the 1 over here and this 4 over here. So now we know that this 1 is the lowest number in the entire array and that this 1 is definitely in the right spot. Next, we do the exact same thing, but we start at the next position in the array. So we're looking at 5. 5 is the current lowest number that we've seen. And then we move on to 4. Is 4 less than 5? Yes, so now 4 is the lowest number we've seen. And then we move on to 2. Is 2 less than 4? Yes, it is. So now 2 is the lowest we've seen. And then we move on to 3. 3 is not less than 2. And we've now reached the end of the array. And 2 is the smallest number that we've seen. So what we're going to do is take this 2 and swap it with that position that we started at. Now we know that the 1 and the 2 are in their proper positions, and we can move on to starting with this next position. And we do the exact same thing. We start here and find the lowest number. So we start with 4, 5 is not less than 4, 3 is less than 4, and we're at the end of the array. So we do the swap again by putting the 3 here and the 4 here. And now we know the 1, 2, and 3 are in the right positions, and we move on to the next position in the array. So we start with the number 5, and then is 4 less than 5? Yes, it is. We reach the end of the array, and 4 is the smallest number we've seen. So now we swap these two. Now, once we're looking at the very last number in the array, we know that there's nothing past it to switch with, so we know that it's automatically already in the right place. And so that's it, we're done. We now have the array of integers in the correct natural order. Now that we understand how selection sort works, let's jump right into the code. Okay, first let's take care of some of the setup. The first thing that we're going to need is an array of ints to sort. So let's go ahead and create that. We're going to make an int array. We'll just call it numbers equals new int array. We'll give it some way larger arrays later to see how well the sort performs, but for now, just for testing purposes, we'll start with just having it sort an array of 10 ints. Okay, so now we want to generate some random numbers to put into this array. So to generate random numbers in Java, we'll use the random class. Not just some random class, the random class equals new random. Okay, so now we're going to loop through this numbers array, filling it up with random ints. So to do that, we'll use a for loop. For int I equals 0, we'll loop while I is less than numbers.length I++. All right, so for each position in this array, we're going to assign it a random number. So we'll set numbers at I equal to random.nextInt. Now let's use a wide variety of ints, anything between like 0 and 100,000. So now just for testing purposes, let's go ahead and print out our array just to make sure we're filling up the array how we think we are. Now, a good way in modern versions of Java to get a string representation of an array is to use arrays.toString and then pass in your array. Now let's go ahead and run this and make sure we get a nice random selection of ints. 10 ints, they look pretty random between 0 and 100,000, so we're all set. Next, what we want to do is make the call to our not yet implemented selection sort method. And then what we'll do is implement the selection sort algorithm inside that method. So what we'll do is say selection sort and then pass in our numbers array. Now it's of course complaining that this method doesn't exist yet, but IntelliJ makes it easy to go ahead and create this method automatically. But then back up here, right after we call our selection sort method, what we want to do is print out the array again, which should at this point be sorted in order from least to greatest. So now our only job is to implement the selection sort algorithm here in this method. The first thing that might be kind of useful to have here in our selection sort method is a variable that holds the length of our array, just because we'll need it in a couple of spots in the algorithm. So we'll just create an int, we'll call it length, and set it equal to numbers.length. All right, now remember, we want to start with a loop that goes through every position in the array. And then within each iteration of that loop, we'll have another loop that will try to find the smallest element from that point on in the array. Okay, so let's start with the outer loop. We'll say for int I equal to 0. So that's starting at the very first element in the array, the 0th element. We'll keep looping while I is less than the length of our array. And of course, iterate I each time. Okay, so now within each iteration of that loop, we want to find the smallest number from that point on in the array. Inside this loop, first we're going to want a couple of variables. One will be the lowest number that we've found so far while iterating through the rest of the array. The second variable will be the index, the position in the array where we found that smallest number. And that's because once we identify that smallest number, we need to know where it was in the array so that we can swap it to the front where it belongs. So first let's create a variable for the min number that we found so far, and we'll initialize it to this first value that we're looking at. So for example, if our outer loop is currently at this number 4, we'll start with our min being 4, and then iterate from there to the end of the array trying to find the smallest number. So we'll set our min equal to our numbers array at I. And then we'll want that other variable for the index where we found that min. So index of min, we'll set that equal to I. So now is when we're going to have this inner loop that loops from our current position all the way to the end of the array, trying to find the minimum number. So for that, we'll use another for loop. And since we already used I, we'll use j for this one. And we're going to initialize it to I plus 1. So that's going to be just one past this current starting position. And we're going to keep looping while j is less than the length of our array. And then, of course, iterate each time with j++. And actually, one thing I missed, up here in our outer array, we don't want to go all the way to the end of the array for this. Remember, we can stop at the second last position in the array, because once we get to the very last position, there's going to be nothing to swap it with. We know that it's already where it goes, and so there's no reason to actually look at it. So for this outer loop, instead of looping while I is less than length, we can loop while I is less than length minus 1. Okay, now back to this inner for loop. So it'll be looping from 1 past our current position in the array all the way to the end, trying to find the minimum number. So for each number that we run into, we're going to say if the value of our numbers array at that position, j, is less than our current min, then we have found a new it with. We know that it's already where it goes, and so there's no reason to actually look at it. So for this outer loop, instead of looping while I is less than length, we can loop while I is less than length minus 1. Okay, now back to this inner for loop. So it'll be looping from 1 past our current position in the array all the way to the end, trying to find the minimum number. So for each number that we run into, we're going to say if the value of our numbers array at that position, j, is less than our current min, then we have found a new smallest number. So we need to set our min equal to the value of our numbers array at position j. We have a new minimum. And then we want to remember where we found that minimum to. So we're going to set index of min equal to j. So now, once we are done with this inner for loop, once we have popped out of this inner for loop, we should have found our minimum number and we should know exactly where it is. So going back to our example here, let's say we were starting with this number 4 and we loop through the entire rest of the array to find the minimum, and we've identified, oh, 1 is our minimum. So we want to take where we found that minimum and swap it with the number that we were starting with, like this. So here it'd probably be a good idea to implement some kind of a swap method. Now there's a few things we have to provide to a swap method. First is the actual array inside which we want to swap 2 positions. And then we need to send in the 2 positions that we want to swap values at. So here we want to swap the numbers that are at position I with the index where we found that minimum number. We want to take that smallest number that we found and move it to its correct position in the array. All right, so now let's go ahead and auto-generate this method. And we'll rename these int parameters here to make it a little bit more general. We'll just call it int a and int b. Now to do a simple swap of 2 elements in the array, first you're going to need some kind of temporary variable to hold one of them while you do the swap. So we'll set int temp equal to our numbers array at position A, and then we're going to set our numbers array at A equal to the value of our numbers array at B. And then all we have to do is set the value of our numbers array at B equal to that temporary value that we set off to the side. Now I think that should be it. Now once it gets out of this outer for loop, the entire array should be sorted in the correct order. Let's give it a run and see if it works. Okay, so here is our... In this video, we're going to be coding the selection sorting algorithm. We'll just call it int for the numbers that are at 2 elements in the array. First, you're going to need some kind of temporary variable to hold one of them while you do the swap. So we'll set int temp equal to our numbers array at position A. And then we're going to set our numbers array at A equal to the value of our numbers array at B. And then all we have to do is set the value of our numbers array at B equal to that temporary value that we set off to the side. Now I think the first element in the array, the 0th element, we'll keep 1000, so we're all set. Next, what we want to do do is we'll keep trying to find. Once we get to once we are done with this inner for loop, once we have hopped out of this inner for loop, we should have found, and we've identified found equal to our numbers array. This outer for loop, the entire array should be sorted. Sorted in the correct order. Let's give it a run and see if it works. Okay, so A, and then we're going to set our numbers array at A equal to the value of our numbers array at B. And then all we have to do is set the value of our numbers array at B equal to that temporary value that we set. Off to the side. Now I think that should be it. Now once it gets out of this outer for loop, the entire array should be sorted in the correct order. Let's give it a run and see if it works. Okay, so here is our initial completely unsorted array, and here it is afterward. Looks like in perfectly sorted order. Awesome. So we've successfully implemented our selection sort algorithm. Now comes the fun part where we get to see how well it performs with larger and larger arrays of ints. So first, let's just take a second and set up some really quick timing code. So right before we call our selection sort algorithm, we're going to create a long to hold the current time. We'll call it start time equals system.current time millis. And then we'll do the exact same thing afterwards, but we'll call it end time. And then right before we print out our sorted array, we'll print out that it took however many milliseconds. So we'll calculate that as just end time minus start time, and then ms for milliseconds. Okay, now let's go ahead and give this a run to make sure it works for our teeny tiny array of 10 ints. All right, so for an array of 10 ints, it took basically no time at all, which is to be expected. Now let's take it up a notch, and let's say we wanted to sort out, let's just say 10,000 ints. Okay, so for 10,000, it went from 0 to 87 milliseconds. So it returned pretty quickly, but it's kind of starting to slow down. Now let's do 10 times that and step it up to 100,000. Here we go. Okay, it's printed out the before state, the unsorted array, and it's still running. Oh, okay, it finished. So it took about 6,500 milliseconds, about 6.5 seconds to sort 100,000 ints. So it's starting to get noticeably slow. Let's try just stepping it up to 300,000. Taking its sweet time on this one. You guys played that new Zelda game? I hear it really does live up to the hype. I just haven't had time to play it yet, but I am looking forward to it. Oh, looks like it finished. Okay, so 300,000 ints took 51,936 milliseconds. So about 52 seconds, almost a full minute. So let's go ahead and step it all the way up to 1 million. Good luck, computer, sorry. All right. Yeah, so I think I'm gonna let this do its thing, and I'm gonna go do something useful with my life while it runs. So I'll see you when it's finished. All right, so have we finished? Yes, we have. And only took 645,000 milliseconds, like 10 or 11 minutes. That's a pretty long time. So you probably wouldn't want your production-ready enterprise application to be using selection sort to sort 1 million ints. So we could do 10 million, 100 million. I'll leave that as an exercise to you, the viewer. If you have the time to dedicate to that, go ahead and leave in the comments below how long it took for your
over 200 tech jobs and
algorithm inside that method.
Holy crap.
To put these elements in their natural order, which for integers is going to be least to greatest. So let's look at this set of integers as an example. So we start at the first position here. And what we're going to do is search from this point in the array all the way to the end and remember the index of the smallest number that we find. So we do that starting at 4. So the current lowest number we've seen is 4. And then we look at 5. Now, is 5 less than 4? No, so 4 is still the lowest that we've seen. And then we move on to 1. Is 1 less than 4? Yes, it is. So far, 1 is the lowest number that we've seen. And then we'll move on to the 2. Is 2 less than 1? No, 1 is still the lowest. And then we move on to 3. Is 3 less than 1? No, 1 is still the lowest. So now we've gotten to the end of the array, and we know that the number 1 the binary search algorithm in Java. Binary search sounds like it could be really complicated, but it's really not so bad once you understand how it works. It's also a great algorithm to learn to write for a beginner. I'll also show you how you can do a binary search with just one line of code using Java's built-in libraries. As always, my full Java course is available in a link down in the description. There you'll find over 8 hours of exclusive Java lessons covering dozens of topics, so go check it out. You can also find the full source code for this video in a link down in the description, so go grab it. First, let's just talk about what exactly a binary search is and why it is better than a regular search. Binary search is just a way that you can check whether a specific value is present inside a sorted array. So let's say we had some array of integers, for example, that was 1, 2, 4, 5, 7, 9, and 11. All any search algorithm does is just take some number that you give the algorithm, let's say we gave it the number 9, and it just tells you whether or not that value exists anywhere in the array. So normally, if you didn't have an algorithm like binary search, if you wanted to check whether a given value was in your array, you could just iterate through every item in the array, checking its value until you found the value that you were looking for. Now that's totally fine, and it does work, but the problem is if you have an enormous array of integers, it can start to become kind of slow because it has to check every single value in the array until it finds the one that it's looking for. But if you know that the array that you're looking at is sorted in order, so in the case of integers, they go from smallest to largest, like we have here, then you can instead use the binary search algorithm to get your result much faster than you could with a regular iterative search. Now, it is very important for your binary search to work at all that the values that you're giving it have to be in order. That's very important. If you're working with an array that is not currently in order, you're going to want to sort it in order first. And you can do that in any number of ways. I've got lots of videos about sorting algorithms, so go check them out. But I just want to make it clear that it is important. Your array has to be in order for binary search to work. All right. So here's how binary search works. Now, instead of just starting at the very beginning of the array and checking every value, what we're going to do is first check the value at the very center of the array, the middle value of the array. The array here has 7 elements, and so our middle element here is the number 5. So now that we've selected the middle element in our array, what we do is compare it to the number that we're looking for. In this case, we're looking for the number 9. So first we check, is this the number that we're looking for? And if it is, great, we're done and we found it. But in this case, it's not. 9 does not equal 5, so we have to continue. So what we do is say, okay, is 9 greater than 5 or less than 5? Here, 9 is greater than 5. So what does that mean? Because we know that our array is sorted in order from smallest to largest, we know that if the number 9 is in this array, it is going to be to the right of the number 5. Now, the important part of what that means is that we can completely eliminate looking in that entire half of the array that is less than 5. That is the key to how a binary search is so much faster than a regular iterative search. The next step in binary search is basically just to redo the binary search in just that half of the array that might contain the value that we're looking for. So basically, we're going to do a binary search for the number 9 here with just these 3 values. And we're going to do that exactly the same way as we did before. So first, we're going to choose the middle element of our array and check its value. So here, that is now the number 9. Now we compare that number to the number that we're looking for. Is 9 9? Yes, it is. So we found the number that we were searching for. Now, after the algorithm finds that number, all it returns is the index of that number in the entire array. So here, that 9 is at index, so this is 0, 1, 2, 3, 4, and 5. So our binary search algorithm would return the number 5 because that is the index where we found the number that we're looking for. But if that hadn't been the number we were looking for, let's say instead of that we were looking for the number 7, well, we would just continue doing the exact same steps we did before. We would have compared 7 with 9 and said, okay, 7 isn't equal to 9. Okay, is it less than 9 or greater than 9? Well, 7 is less than 9. So that means that, again, because our array is in sorted order from smallest to largest, we can completely eliminate the entire right half of that subarray. We don't have to look there. We know it's not there. So then we can repeat that binary search algorithm on just the one small part of the array that's left. And then, of course, we see, okay, 7 equals 7, so we found our value there. So you might be thinking, all right, well, what do you do if the value that you're searching for actually isn't in the array? So let's say instead of 9 or 7, we were looking for the number 6. Well, up until this point of the search, things would have gone exactly the same way. But now we're comparing, okay, is 6 equal to 7? Well, no, it's not. But the problem is there's nothing else left in the array. So we know that it is not present in our array. How we handle that usually in a search algorithm, we don't throw an exception or anything like that, but instead we just return a -1. We know that -1 is not a valid index of the array, so we return -1 as a way of just saying, sorry, I didn't find the element that you were looking for in the array. So maybe this gives you a glimpse at why the binary search algorithm is so much faster than a regular iterative search. Let's say that you had an array of like 1,000,000 items in it. Now, a regular iterative search would just start at the beginning and it would say, okay, I've got to check all these 1,000,000 items and see if it's in here. But a binary search can start in the middle and say, okay, is the thing I'm looking for greater than or equal to this? And then it can immediately completely remove half of the entire array. So in just one step, the binary search algorithm reduces the problem that it's dealing with by half. I think that's enough of this. Let's jump right into the code. All right, so to implement our binary search algorithm, first, instead of writing our algorithm right there in the main method, let's go ahead and create a separate private method that will do the binary search that we will call from our main method. So we'll go ahead and make a new method here, a private static. Now the return type of our method is going to be an int because we want to return the index of the value that we find if we find it. We'll call it binary search, pretty creative name. Now our binary search algorithm has to take in two parameters. First, it has to take in the actual array of ints that it's searching in. We'll just call that numbers. And then it also has to take in the value that it's searching for. So we'll call that one number to find. So here's how I think we're going to do this in the code. So I think we're going to use two pointers. We're going to have one that's at the very first element in our array and one at the very last element in our array. And what we're going to do is find the middle value between those two pointers. And then we check whether the number that we're looking for is equal to that value or if it's greater than or less than that value. Let's say that we find that the number that we're looking for is less than that middle value. We're going to take that pointer that's currently at the end of our array and we're going to move it just to the left of that middle number. And then we're going to repeat our binary search algorithm with just that half of the array that's contained within our two pointers. Now, if the number that we were looking for happened to be larger than that middle number, we would instead take our low pointer and move it just to the right of that middle number. And we continue our binary search with just that half of the array. So you can kind of see how it works, right? What we're going to do is keep dividing what we're looking at in half by moving our pointers until we zero in on that one number that we're looking for, and then we can return the index of that number. So first, let's go ahead and create those two pointers that we need. They'll just be ints. We'll just call these pointers low and high. So first, we'll create our low pointer. So int low equals 0 because we want to start it at the very beginning, the very first element of our array. And we also need another int. We'll call it high. And we want to start that at the very last index of the array. And we can get that index by calling just numbers.length and then subtracting 1. So the next part of our algorithm is kind of going to be the main part of it, which is actually going to be a while loop. Now, our while loop is basically going to keep looping until our two pointers, cutting off half of the array as they get closer and closer to each other, until our two pointers cross each other. So the condition in our while loop is going to be while low is less than or equal to high. Now that we have all this set up, the first step in this meaty part of the binary search is we have to identify the index of the middle item in the array that we're searching in right now. So let's go ahead and create that. We'll say int like middle position. Now that middle position is basically the average of our low and high indices. So we can get the average of low and high just by taking low plus high and dividing by 2. Next, we need to identify what the value is at that index. What actual number is at that spot in the array? So we'll use another variable for that. We'll call it int middle number, and we'll set that equal to the value of our numbers array at that middle position. So now what we want to do is check whether the number that we're looking for, our number to find, is equal to that number or less than or greater than that number. First, let's check if it is equal to that number. So we can say if the number to find is equal to this middle number, then that means that our search is done. We have found the number that we're looking for. So all we have to do is return the index where we found that number. And that index is our middle position variable. So all we have to do in this case is return middle position. But if this wasn't exactly the number that we were looking for, we have to deal with that situation. So what if the number that we were looking for, our number to find, is less than our middle number? So in that case, remember, what we want to do is we want to take our high pointer and move it just to the left of our middle pointer, our middle position, because we know that the number that we're looking for is less than this middle number right now. So to do that, we can just take our high pointer and set it equal to the middle position minus 1. So that'll make it just to the left of that middle position index. So now we know that the number that we're looking for is not equal to the middle number. We know that it's also not less than the middle number. So at this point in the algorithm, we know for sure, if we put in an else here, we know that our number is greater than the middle number. So we don't even need to add another if condition if we don't want to. You can if you want. You can add, okay, if number to find is greater than middle number. If that makes you feel nice or it just makes more sense in your head to have it, you totally can. But at this point in the algorithm, we just don't really need it because the way the logic works, we know it's not equal because it would have returned already. We know that it's not less because it would hit this if. So in this else, we know that it is greater. Now, since we know that, we can take our low pointer and set it just to the right of that middle position. So to do that, we'll take low and set it equal to middle position plus 1. So now what this while loop will keep doing is moving those high and low pointers closer and closer together each iteration until they meet and eventually find that number that they're looking for, or eventually the low pointer will be set to one higher than the high pointer. So what that means is our high and low pointers move closer and closer to each other until they met at one single number. And then they still didn't find the number that they were looking for, and so they crossed each other. So at that point, it will kick out of this while loop. So what that means is outside of this while loop, we know that we didn't find the number that we were looking for. It wasn't present in the array. So all we have to do in that case is report our failure by returning just the number -1 to indicate, sorry, we didn't find it. That is everything we need. I think this is a complete binary search algorithm. All we need is some code that calls it to do some testing. So first we're going to need an array of integers to pass into our search algorithm to start to find some stuff in. So we'll just call this int array ints, and we'll just go ahead and give it some values. Let's use the same array that we did in the whiteboard thing there. So that was just 1, 2, 4, 5, 7, 9, and 11. So now what we want to do is call the binary search method that we implemented down here, and we have to pass in first the array that we want to do the search in. So that would just be ints. And then we want to put in the number that we're looking for. So let's say we want to search for the number 9. And then we'll go ahead and print out our results. Otherwise, we'll never know what the result was. Okay, there we go. Now let's go ahead and run this and see what happens. Here we go, cross your fingers. Okay, so it returned 5. It's saying that the number 9 is at index 5 in our array. So let's check to make sure that's right. So that'd be 0, 1, 2, 3, 4, and 5. So that's right, it returned the correct value. All right, so that's one test that is successful. But let's hit it a little bit harder with some more values to make sure that it returns the right result every time. So let's say we were looking for a number that did not exist in our array. So let's look for the number 8. So if we go ahead and run that, we get -1, which is exactly what we're looking for. Because 8 didn't exist in the array, the algorithm should report that by returning -1. So let's try some other like edge cases. Let's say we wanted to look for like the very first thing in the array. So let's say we were looking for the number 1. It should return an index of 0, and it does. Awesome. And let's look for the highest element in our array, which is 11. And it returned 6, which is correct. 0, 1, 2, 3, 4, 5, 6. Looks good. As a quick side note, if you want, you can change this algorithm to, instead of using a while loop, you can change it to be a recursive algorithm with just a couple of pretty small tweaks. Now I think I'll leave that as a small exercise for you to figure that out if you're curious. I do have an entire video on recursion if you want to go check that out to learn about recursion generally. But I'll also link to my recursive solution for this algorithm in the description below. So if you get stuck, that the values that you're giving it have to be in order. That's very important. If you're working with an array that is not currently in order, you're going to want to sort it in order first. And you can do that in any number of ways. I've got lots of stuck, go ahead and check that out. Now, I also mentioned at the beginning of this video that you can do a binary search with just one line of code using Java's built-in libraries. So here's how you can do that. So what you can do is call arrays.binarySearch. That is a method provided to you automatically in Java, and that's in the java.util.arrays package. That's where you can find this class and call this method. And then you can just pass into this binary search method exactly the same parameters that we passed into our binary search, which is first the array that you want to search in. So in this case, it's ints, and the value that you want to search for. So again, let's go ahead and search for the number 9. And let's go ahead and change this to look for the number 9 too, just so we can compare the results. And we also have to go ahead and actually print out the result of our Java library call. So I think that's it. Let's go ahead and run it, and hopefully we get the same output from both of these calls. And yes, we do. We get 5 from both of them. So like so many things, Java doesn't force you to reinvent the wheel if you don't want to. If you don't want to write your own binary search algorithm, you can just use its built-in one. Just like it has sorting algorithms and stuff built in, you just call a sort method and it does it really, really well. Same as for binary search. But it's still a really good thing for you to know how to do and understand how it works to code on your own. If you enjoyed this video or learned something, of course,